Hello, welcome to the second book about large language models. This is apress-ebook from the last year, building applications with large language models. The formulation in the title of the book, Applications with Large Language Models, does not mean concrete applications or concrete examples. There are no such in the book, but explanations about history, evolution, content and technique and so on of natural language processing, large language models, transformer architecture, attention mechanisms, only two, self-attention and multi-head attention, and so on and so on. The biggest chapter in the book is dedicated to evaluation of large language models. Special criteria, technique, tools, frameworks are explained in this chapter. So it can be useful for understanding which exactly qualities your new large language model or application with large language model must have. Also, ethic problems are discussed in this book, and the author describes three groups of people according to their relation to artificial intelligence, to generative artificial intelligence. First group understand artificial intelligence very positive, that artificial intelligence solves all problems of humanity. The second group sees AI negative. For example, AI took working places from humans. And the third group sees both positive and negative sides of artificial intelligence, and the author belongs to this group. I personally fall somewhere between first group and third, closer to the first. I believe and I am sure that artificial intelligence really helps to solve a lot of problems, and mistakes and misusing are everywhere, in any area of knowledge and activity. The book begins with an example of 3 sentences with the same word in different meanings. And the author explains that this is only one characteristic of language that computer is expected to learn. And on this place I would expect that it comes detailed explanation how computer does this, learn such characteristics of language. But there are no such explanations in book, but explanations about natural language processing, common explanations about natural language processing, large language models, and so on. So the reader is left to understand such details themselves. And here it is necessary to be very careful, because some formulations in the book are imprecisely and can be understood wrong. For example, in the chapter 1 on the page 16 there is formulation. So the models that can predict the next token based on a previous sequence of tokens, content, are called language models. This sentence can be understood as all language models work in this way. Predict the next token based on a sequence of tokens or on previous sequence of tokens. And previous sequence of tokens is content. But this is not true. Only one group of language models works in this way, namely GPT-style language models. Language models with architecture generative pre-trained transformers. Other kinds of language models work differently. For example, BERT-style language models understand both sequences, previous and further, and can recognize or predict a word between these sequences. These are bidirectional language models. Bidirectional encoding representation from transformer. And there are also several or perhaps many large language models with another architecture, not transformer architecture, and with another attention mechanisms. And the word content is also in this sentence not precisely used. Content is general term in natural language processing and in large language models. It means any surrounding words or informations that can be useful or helpful for understanding the meanings. Not only content is not only previous sequence of tokens. So it is necessary to be very carefully. If you read the same books as I did, you will possibly remember on these other books while reading this book, Building Applications with LLMs. Especially while reading explanations about NLP techniques, tokenization, stemming, and lemmatization, you will possibly remember the article in the Retrieval-Augmented Artificial Intelligence, Improving Subword Embedding Using Morphological Informations. This article tells about study for tokenization using morphological informations, exactly about prefixes and suffixes. Words are tokenized by cutting of prefixes and suffixes. And this kind of tokenization results in less tokens as usual and in more efficiency of large language models. The techniques of natural language processing, such as stemming and lemmatization, are something another. They cannot be combined with subword embedding, with using of morphological information, and cannot replace this approach. Stemming and lemmatization are reducing of words for normalization of text, for better edition or understanding. By stemming, a word will reduced to a basic form, stem, and this form had not to be correct morphological form. For example, stem from word happiness is happy with I on the end, not really correct word happy with y on the end. Suffix ness is cutted from the word, and the stem basic form of this word stay after stemming. Lemmatization reduces word also to basic form, but this basic form is correct morphologically or linguistical. It uses also content and meanings in the text or of the text. For example, lemma basic form of words am, was, were, been, and so on is be. Correct, real word. The study of the article in De Gruyter-ebook, Artificial Intelligence, emphasizes that results of this study are very positive and promising. So it is really very useful to use morphological rules in large language models. Of course, prefixes and suffixes are not enough morphological information for such approaches. So there are already several or perhaps many similar studies in this direction. For example, morph BPM, byte pair encoding, and Stochastic. Morph BPE is complex of approaches of different processes. For example, some tokens can be united in pair of tokens if they often comes in this way in real language. And there are also special techniques to recognize exactly word roots in the language with complex morphology, and so on. And Stochastic allows large language models to look inside of a token by dividing a token in two with stochastic principle, and so on. Of course, artificial intelligence and large language models and natural language processing are great inventions in the history of humanity, and these inventions are next steps in a lot of scientific work. And of course, many works of linguists from all over the world build basic of such inventions as large language models, natural language proceedings, and so on. I believe that who is interested in programming languages is also interested in natural languages and in linguistics. At least I do. And several years ago, I read fantastical book, Soviet book, The authors are scientists of Academy of Sciences of Soviet Union. This is a book from 70 years from the last century. I read this book in Russian and in German. German translation, this book in German translation is available on German libraries and by Google Books and so on. There are 3 volumes of this book. Volume first is about existing forms, functions, and history of languages, relationship between language, between speaking and thinking, and so on. The third volume is about special methods of linguistics, and the second volume is about inner structure of language. This passes very good to our today's book or topic. To be objective, I asked Gemini to find if this information linguistic research from the last century, from the 50 years ago, pass to explanations of our today's book, built-in applications with large language models, and if these linguistic statements and research from the last century are useful for development of large language models, natural language processing. And Gemini found a lot of such informations which are very important for our modern landscape of tools, large language models, natural language processing, and so on. A report of Gemini to this my question is on many pages. I name only several such explanations in this linguistical book. For example, it is explained that word has 2 parts: form and function. This is exactly what about is example with the same word but different meanings. Form is the same but functions are different. Book explains how it comes to the different meanings and why. Then book explains also that language is a well-structured system and very complex system. Of course, large language models must understand this, and indeed language is a complex and well-structured system. And in an organization of large language models, in a representation of language, is this well-structured system, coordinate system, where every word, every token is vector, coordinates of a point in coordinate system. Then the book explains also that language is multi-tier system of several levels: phonology, morphology, syntax, grammatic, lexic. And all these levels had to understand each other in large language models. And this is especially important for tools text to audio, audio to text, and so on. Video to text, and so on. Then the book explains special relations between language elements. This can be hierarchical relations or paradigma relations between language elements which can replace each other. This comes in large language models also, or had to be realized in large language models also. Different functions of language elements are explained in this book, and so on and so on. Everything is necessary for development of large language models. This linguistic work is truly, and other linguistic works, the whole linguistic work of many scientists in the world is theoretically basic of large language models and natural language processing. And of course, if I may say something about future of large language models, then I say that more and more linguistic rules had to be realized in large language models. This book contains not only own statements or founds of scientists of Soviet Academy of Sciences, but also analyzes a lot of statements of very many scientists from all over the world. And in our today's book, Building Applications with LLMs, every chapter begins with statement of some famous person. For example, the first chapter begins with a statement that language is a part of our human organism and not less complex. This is true. This is sentence from one philosopher. In the linguistic book, there are several explanations and statements from Wilhelm von Humboldt, and I'd like especially two of them. First is that one can only truly understand a language if one sees a language not just as a fact or as a thing, but as a creative activity. Is this true? Pass this to LLMs? Yes, of course. LLMs and artificial intelligence brought humanity to new, higher level of understanding of language. And the second sentence of Wilhelm von Humboldt tells that the main function of a language is to materialize intellectual activity of a human. Is this true? Is this realized in large language models? I say yes. Large language models, artificial intelligence, natural language processing materialize our humans' intellectual activity. Have a nice day.